Welcome to Ask and Learn.
In this problem, we need to use information from the appendix in order to solve for the equilibrium constant of the solubility reaction of CaF2. The first thing that we need to do is write out the chemical reaction describing the dissolution of solid calcium fluoride. When this solid dissolves in solution, we know that it breaks up into the ions of the two different elements that make up this compound. So that would be calcium, which in aqueous solution has a charge of 2+, and fluorine, which when it is in aqueous solution has a charge of -1. And to balance out this reaction, we need a coefficient of 2 here. So now we can use this equation on the bottom to solve for that equilibrium constant of this solubility reaction. And we are told that we want to solve this at a temperature of 298 Kelvin, and we know that R is a constant. So the only thing that we need in order to solve for this equilibrium constant is the change in Gibbs free energy of this reaction. And the way that we solve for that delta G reaction is to use this equation outlined in red, where we find the total change in Gibbs free energy of the products, and then subtract the total change in Gibbs free energy of the reactants. So we should begin by solving for delta G of reaction. We break up this equation into the products and reactants term, then we can solve for each one separately. And we start with the product side. We see that we have 1 mole of Ca2+ and 2 moles of F-. So we have 1 mole of Ca2+ and 2 moles of F-. And each one of these ions have their own value for the change in Gibbs free energy of formation at standard conditions, which we can look up in the appendix. And so now when we multiply these values together, units of moles cancel out, so that we are left with total Gibbs free energy change units of kilojoules. And when we add them together, we can get the total change in Gibbs free energy of the products for this solubility reaction. And now we do the same for the reactants, and we see we just have 1 mole of CaF2. So 1 mole of CaF2 multiplied by its change in Gibbs free energy of formation at standard conditions gives us the total delta G of the reactants. Now we take the total change in Gibbs free energy of the products and subtract that same quantity for the reactants to get the total change in Gibbs free energy of this reaction, delta G reaction, to be about 55.96 kilojoules. And now we plug that value into this equation to solve for KSP. So when we do that, we can see that KSP equals e to the power of negative delta G, which we just solved for to be 55.96 kilojoules of energy, divided by R times T. And R is 8.314 joules per mole Kelvin. But we should convert this into kilojoules by dividing by 1,000. So that when we divide the numerator and the denominator, units of kilojoules cancel out, and then we are left with the temperature of 298 Kelvin. And so we can cancel out units of Kelvin. When we plug that all into the expression for KSP, we can get a final answer for the solubility product equilibrium constant to be about 1.6 times 10 to the power of -10. And this answer will be unitless.